Hey guys, this is Recitation 15. I'm going to go ahead and get started. Balance the following reactions in an acidic solution. So remember, acidic means you're using H plus to balance it. If you do have to do something with a basic solution, you can always do H plus and then add an OH minus to either side. And then you end up with H2O and OH minus, and it'll still be same charges and everything will balance, but it's in a basic solution instead. But this is an acidic solution, so very straightforward. So remember, the first step is to divide everything into half reactions. Zinc goes to zinc 2 plus, and H plus goes to H2. Zinc goes to zinc 2 plus. The first step is going to be to balance all the non-oxygen and hydrogens. They're all balanced. All the oxygens are balanced because there are no oxygens. And then the last step, we'll want to make sure all the hydrogens are balanced. So we can do that. And then, so all of our elements are balanced. And then we'll just want to make sure that all of our charges are balanced. So to go from a charge of 0 to 2 plus on this zinc, you'll need to subtract you'll need to add a negative. You'll have to add a negative charge, or in other words, sorry, I already did this once, and there was no sound on, so I have to redo it, and it's taking me a while. So zinc goes to zinc 2 plus 2 electrons, right? Because 2 plus 2e minus equals 0. We'll do the same thing on this side. 2h plus 2e minus goes to H2. Let's see, both of those have two electrons. So we'll go ahead and cancel those out, add these together. And then we get zinc plus 2h plus goes to zinc 2 plus H2. And there's our final reaction. So we'll do the same thing for this other one, divide it into half reactions. CO goes to CO2. And then we'll balance all of the non-oxygen, non-hydrogen elements. Carbons are already balanced on the other one. Balance the oxygens, so Fe2O3 goes to 2Fe plus 3H2O. Then we have 3 oxygens on either side. CO plus H2O gives us 2 oxygens on either side. And then we will balance the hydrogens. 6 hydrogens on the right side, so 6H plus on the left side. CO plus H2O, just 2 hydrogens on that side, so we'll add our 2H plus. And then we need to add our charges, just like above. We want to make both sides equal to the same thing, in this case 0, so we'll add 6 electrons to balance out the positive charge of the hydrogens. And then same thing on this side. We'll need 2 electrons to balance all the negative charges. Then we want each side, we want these to be able to cancel out. So we'll multiply this by the least common, I guess it's the least common multiple. We'll multiply that by 3, so we get 6 electrons here. Let's go ahead and add these up. 3CO plus 3H2O goes to 3CO2 plus 6H plus 6E minus. Then we can go through and cancel out our like terms. So 6E minus on both sides. We have 6H plus on both sides. We have 3H2O on this side, 3H2O on this side. Then we can combine them. So we get Fe2O3 plus 3CO goes to 2Fe plus 3CO2. I didn't do this on the last one, but we can check and make sure all of our charges and atoms equal each other. So all 4 compounds have 0 charge, so that's good. 2 irons, 2 irons, 3 oxygens plus 3 oxygens is 6 oxygens, and 3 carbons, 3 carbons. So there is our final answer. Chemicals were mixed and observed in a redox reaction. We're ranking reducing and oxidizing strength of the different compounds. So first we'll want to identify which is a reducing agent and which is an oxidizing agent. So Na goes to a charge from 0 to +1, and HCl goes from a charge of +1 to 0. So remember, oxidation is lose, reduction is gain. That's how I remember it. Oil rig. So oxidation, you're losing electrons. So Na goes from a 0 to a positive charge. It's losing a negative charge, right? Minus a negative is a positive. So that's being oxidized, which means that sodium ion is our reducing agent, making HCl our oxidizing agent. This one, there's no reaction taking place. But we can figure out the reaction. So HCl, we're going to assume it goes to some sort of gaseous H2, and then probably like AgCl, and that's not balanced, but we don't need it to be. So in other words, we know if this reaction, the forward reaction, doesn't take place, the reverse reaction does. And let's see, so our AgCl goes from a positive to a 0, which means it is being reduced, making it our oxidizing agent, and H2 our reducing agent, excuse me. And then our last one, again, sodium goes from a 0 to a positive charge, making it the reducing agent, AgCl our oxidizing agent. We'll also go through, so those are all of our strong oxidizing and reducing agents. The opposites are going to be our weak reducing agents and oxidizing agents. So if it's a weak reducing agent on one side, it's a strong. If it's a strong reducing agent, then the conjugate will be a weak oxidizing agent. So we'll go through and label all those again. Okay. And then, so now we need to figure out which reducing agent is the strongest. So the one that always has a strong reducing agent is going to be the sodium. So sodium is our strongest. And our weakest, our one that always has that never is the reducing agent, that's always the weak reducing agent, is going to be silver. So that's our weakest reducing agent. And then H2 is somewhere in the middle. Then our oxidizing agent is going to be the exact opposite. And again, you can see that in that anything with Ag plus is always going to be a strong oxidizing agent, whereas anything with Na plus is always a weak oxidizing agent. And there we go. Still have about 5 minutes. It's going faster than last time. That's good. Complete the following table by drawing the full, condensed, and skeleton structures. Okay, so C3H8. So let's start out by just drawing 3 carbons and figuring out how to get 8 H's on them. So it looks like we can just give all the carbons hydrogens until they have 4 bonds each. That gives us 1, 2, 3, 4, 5, 6, 7, 8 hydrogens. And then we will need to draw the condensed structure. So we have CH3, CH2, CH3. Then our skeleton structure, remember our hydrogens are implied, so we just need to make sure we add our 1, 2, 3 hydrogens. And that's our skeleton structure, which the dots don't need to be there, but that was just to show you where they were. So there's our skeleton structure, C2H2. So we'll go ahead and draw the C's first, and we'll draw hydrogen on each carbon. And now remember, carbon always has 4 bonds, and we don't have any other H's to give it more bonds, so we'll have to do, we'll try giving it a double bond, then it has 3 bonds each. If we give it a triple bond, it has all 4 bonds. So that's our full formula. We can do CH. Make sure you draw in that triple bond, because that's something you have to draw in when you're doing the condensed form. So you have CH. Then your skeleton, you can just draw 3 lines, because you have your hydrogens are implied, and you have 1, 2 ends to that are your carbons. Okay, CH3, CO, CH3. So let's start by drawing our carbons again. And we can draw in our hydrogens. It looks like there are 3 hydrogens on either carbon at the end. Then we have 1 oxygen. And remember, oxygen is always going to make 2 bonds, and carbon is always going to make 4 bonds. So we'll make that a double bond so that we have all of our bonds, I guess, filled up, you could say. And then it looks like all the carbons have 4 bonds, and the oxygen has 2 bonds, and all the hydrogens have 1 bond. So that's our molecule. And then for our condensed, we'll just write out the carbons and hydrogens, right, in their condensed form, and then we'll still need to put that oxygen in there, because that's just what you have to do. Oxygen isn't, I guess, that double bond and the oxygen. You put those in there. And same thing for the skeleton formula. Again, we can do our carbons and hydrogens. Those are all, we have 1, 2, 3 carbons, kind of like up above, and then we need to add the oxygen so we don't, because otherwise we would just be implying that if we did it like just half a triangle, it would be we'd be up here in the first part, but we want to add the oxygen. Okay, C4H8. So let's try doing our 4 carbons. And we have 1, 2, 3, 4, 5, 6, 7, 8. That doesn't look right. Let's see. So we have, this carbon still needs another more bond. So that's not what that's going to look like. So let's try making it into a ring and see what happens. So we can do 1, 2, 3, 4, and 1, 2, 3, 4, 5, 6, 7, 8, so that'll work. Okay. Our condensed formula. See, well, these are all CH2s, I think. Just for clarification, I'm going to go ahead and draw in all the bonds between the carbons. I think that's how you would draw it. My key was wrong, so it showed it as something different. But that's what the formula looks like. And then when we do our skeleton, remember we have our 4 carbons and they're in a ring. 4 carbons in a ring. And remember, all those hydrogens are implied, so that is what our skeleton looks like for that. Identify the functional groups for each molecule. I'm going to save this for the next video.